So yesterday we talked about some pretty easy ones where it was pretty clear exactly how to set it up, because what was inside the parentheses would be the u, and then your du was directly outside. So it's like the problem was almost exactly done for you. So today we're going to look at situations that are a little more complicated, just tiny, tiny bit more complex than that. Not too much worse, but a tiny bit more worse. You got to put your brain in for low a little bit and get some traction. So let's say we've got the index.
Put your four focus in for low.
It has a button I push.
Oh, does it really?
Yeah.
How does for low?
It's not for low. It's like that car version of for low.
The car version.
There's a car version of for low.
No, but like a little light comes on that makes me feel a lot more safe. So like I got x over 4 minus x squared dx. Okay, so we're going to pick, this is x over, and then in the denominator, it's the square root of 4 minus x squared, and then outside it's dx. So in the numerator, it's plain x. In the denominator, it's the square root of 4 minus x squared. So we're going to pick what's probably going to be the messiest inside bit to be u. So that's what we talked about yesterday. The messiest inside bit is going to be u.
4 minus x squared.
Right. So u in this case is 4 minus x squared. And then we have to find out what du is. So du is equal to whatever the derivative of u is, and then we have to make sure we're adding dx onto the end. So du negative 2x dx. Now this gets a little more complicated because there's no negative 2 anywhere in here. There is, however, an x and a dx, so we're part of the way there. So we have an x and a dx and an x and a dx, but we have no negative 2 up here. So how much of the negative 2x dx, how much of that is up here? Right, but like, okay. Okay. Okay, hold on. Let me try to explain myself. So let's do this at least. So I've got my integral here. I'm gonna move the x kind of out of that. I'm gonna replace this with a 1 over the square root of u, because I'm replacing 4 minus x squared with u. And then I'm gonna put the x down kind of out here so that it's x dx. Are you guys with me on that? Okay. Now, so if I have x dx here, if I get the negative 2 out from there, how would I need to get the negative 2? Let's say this is equal to 1. How would I get the negative 2 away from the x dx? Divide by negative 2. So divide by negative 2, divide by negative 2. I'm going to divide by negative 2 on this side here too, right? So I've got negative 1/2 of du is equal to x dx. So negative 1/2 du is equal to x dx. Are you guys with me on that part? Little tiny bit. So when I'm substituting in an x dx, because that's what I have, I'm not going to put all of du, I'm going to put negative 1/2 du where x dx went, and then I've got 1 over the square root of u. Kind of, sort of?
Yeah.
Aren't you glad I didn't do these first? Okay. So I'll keep that in mind for future generations then. He just does. Just don't worry about it. You've done weird things. Kim, remember when you brought a robotic cat skeleton to school last year?
Oh, yeah.
Nobody asked you anything about that.
Because it's leftover snacks from cheer. That's supposed to still be it.
We were just gonna pass on, okay? We're not gonna worry about it.
Can I have one of those apples?
Sure.
Okay.
I should have thrown it over.
Okay. So anyway, quiet. Back to this. So I'm gonna rewrite this as, so this is u to the negative 1/2 power. I'm going to put the negative 1/2 in front because it's in the bottom, it's in the denominator. And anything that's in the denominator means it's going to have a negative as part of its exponent. Just like if x is in the bottom of a fraction, it's x to the negative 1 power. Like 1 over x is x to the negative 1. And 1 over x squared is x to the negative 2. Yeah, no. So like I'm rewriting this.
Okay. You gotta explain. I'm real confused.
Which part? Yep. Braden just explained everything I did. Okay. So now, at this point, I need to do the antiderivative. So I need to add 1 to negative 1/2, which would make it positive 1/2. So u to the positive 1/2. And then I need to divide it by 1/2, but dividing by 1/2 is the same thing as multiplying by 2, right? Mm-hmm. So I'm going to do 2 times negative 1/2 times u to the 1/2 plus c. 2 times negative 1/2 is going to be negative 1. And then this is, I'm going to write this as the square root of u plus c. And now I can take what u is actually equal to and put it back in there.
How do you get the 2 that you
Because I was dividing by the power it was taken to, and dividing by 1/2 is the same thing as multiplying by 2.
Got you, okay.
Dividing by a fraction is the same thing as multiplying by the reciprocal. Right?
Yeah,
You told me that before too.
Yes, I have.
trusted you a lot, and Mr. Thackeray don't trust teachers.
Okay.
You know it's not to trust
I've shown you why dividing by a fraction is the same thing as multiplying by the reciprocal. I've shown you why. Do you want me to show you again? Okay.
So get us out of doing this, sure.
I'm just lost right now.
I know.
Like where you're getting like, is it when you're doing when you're taking u to the negative 1/2 to u to 1/2, that's when you multiply by 2?
Yes, because you would raise the power by 1 and then divide by the power that your new power.
Right, okay.
And when you're dividing by your new power, I would be dividing by 1/2, but dividing by 1/2 is the same thing as multiplying by 2.
Okay,
That's where the 2 came from.
that makes sense. I meant,
Okay.
I don't have my notes to be like, oh, that's where you get.
Okay. So, guys, shh, quiet. So yesterday's homework, all of them were way simpler than this because you didn't have to do all those extra steps. You didn't have to do this extra part of trying to be, okay, well, du is equal to negative 2x dx. You would have already had negative 2x dx in the problem. You wouldn't have had to do this extra step of saying x dx is equal to negative 1/2 du. You wouldn't have had to do all that extra part. Right? And so the book assignment is going to have you do the extra bit. So let's take a look at the book. Do what? Great. Thank you for that. So let's take a look at the book assignment. The book assignment is on page 202. Page 202. Sure, yep, nope, I probably should be yelling at you more. It's on page 202. We're going to look at 1 through 12. No, it's not. I don't think so.
Even?
No, all.
If it were even, it'd be 2 through 12, James.
No, but it's all. I don't know why you all just can't be nice to each other, but whatever. You're yes, good.
Why can't we be?
Obligatory Mean Girls quote. Great. She doesn't even go here. Yep, she doesn't even go here. I don't. Nope. This whole time, I'm not even your real teacher.
I knew it. You're a hologram.
Yep. Nobody's told me to stop coming here for 5 years now. Okay, so I'm gonna go through the first part with you guys, so let's get started.
Look at that, flip right to it. Not really.
E to the 100.
Mm-hmm.
You have a really hard time drawing those things.
Well, I'm just inconsistent.
Wow. Sometimes you're like, maybe he felt good.
This is the best one I've heard on. You go and find the house.
Okay, so the most inside bit is going to be what you're going to do for u. So in this case, what should be a good idea for u? 4x plus 1? And then what would du be? 4 and then dx. Now there isn't a 4 dx anywhere in here, so we have to solve for dx, so we'd have to divide both sides by 4. So we have that plain old dx is equal to 1/4 of du. Right? Great. No, sure. Lost you guys already. 2 steps in. Okay. Do I need to go through that again? No, it's because there's no 4, like, outside of where the u is, there's no other 4.
And what if there was?
If there,
we do it the same way as you did yesterday.
yes.
Okay.
If there were, then we wouldn't need to do this, but there isn't. Okay. So now, we're going to do our integral. Shh, quiet. So this is 1 over u to the third. And then in place of dx, I'm going to write 1/4 du. Because dx is equal to 1/4 du. So I can move the 1/4 in front. I can change 1 over u to the third to be u to the negative third. I can put du back here. Integral in front. And now I can do the antiderivative. So I'll kick u
So
up.
in this one, you just rearrange?
Yeah.
2.
So I can kick u up to be -2. And then divide by -2. And then times 1/4. And then plus c at the end. Because it's an indefinite integral. The du went away because when I did the antiderivative, both the integral and the du, they act as like parentheses. So when I do, huh?
Are you done now?
No,
Oh.
I will tell you when we're done.
Okay, Mr. Tack.
Okay. No, we're not done yet. So 1/4 times -2 is going to be -1/8. And then this u to the negative second is going to be 1 over whatever u is to the second power. And now I can put u back in here, which is 4x plus 1. Where'd what 4 go?
The 1/4, the 4. 4 times and then
You multiply by next by -1/2.
okay, got it.
You get 1/8.
Now, I'm okay if you don't actually, like, it's only squaring it, so another math teacher,
Plus c on the end?
yeah, I'm sorry, I forgot it. Another math teacher might want you to actually square 4x plus 1. I'm okay if you don't in this case. So your final answer would probably look like -1/8, and then in parentheses 4x plus 1, quantity squared, plus c. And then, yeah, this is the antiderivative of question number 1. I know, right? Okay, let's look at question number 2. Yeah, they dragged E into this now.
Good thing I know that the derivative of e to the x is e to the x.
Right, but this gets more complicated. So e to the 100x dx.
100x is 100.
So what do you think u should be?
100x.
Great. So u is 100x, and then
du is 100.
100 dx. But we don't have a 100 dx in here. So we got to divide both sides by hundo. And then we get that dx is equal to 1/100th du. Am I going too fast? Nope. Okay. So I'm going to replace dx with 1/100th du. I'm going to replace e to the x, or e to the 1/100x with e to the u. He's almost there. Okay. Now I'm just going to do a tiny bit of rearranging here. I'm going to kick this 1/100th over here to the front. So 1/100 e to the u du, and then put my integral there. That's a nice integral right there.
Could do my cookie or
On that bottom.
That's an integral you take home to mama.
no.
Oh my goodness, Mr. Taft.
Okay. So now you have to, so e to the u, the antiderivative of e to the u is what? E to the u. And then 1/100 comes with it. And I add plus c. And now I replace u with what u is actually equal to. This is 1/100 e to the 100x plus c.
Now, you're not going to show us the shortcut later, are you?
No, there is no shortcut. What?
Good but bad.
There's no shortcut ever.
There's no shortcut to this. I'm not lying. I'm not gonna. Next week, I'm not gonna show you another way to do this. This is how you do this.
I wish there was an easier way.
But at least it's not bait and switching.
No, there's no bait and switch. This is how you do this.
You could just look at it and probably take that out if you're going to do.
Me?
Could you probably?
Oh no, I'm really rusty with calculus.
Um,
Give me like another year or two of teaching it, maybe I could.
I feel like this one you could, because like it's gonna have the plus c at the end. And then
E to
you're
the
gonna-
100x.
E to the 100x.
You just need to know about 1/100.
Yeah, that one. Yeah.
Well, yeah, because I guess the derivative is still the same. That's why it's easy.
Okay, let's go through one more together, and then I'll let you guys do
How about
4 more together.
how about 6 more?
Okay.
How about 8? Yeah.
We still got 10 more to go, boys.
Okay, so integral 1.0003 to the. Oh, I don't want this one to be on your assignment. You guys get to skip 3. We'll come back to.
See, guys, I knew we didn't have to do all of them.
Wait, hold on. I'm deciding if I want you guys to do 4 or 2. There's a property you have to use for 3 that I'm going to double back to.
4 looks pretty hard.
Hey, who's in charge here?
Isn't the 10 over x squared?
No, there's a way to do it. I'm deciding if I want to have you.
Well, we already screw it up.
No, okay, just give me a second. Let me think. So I'm gonna let you skip 3 and 4 and 7 and 8. So you're doing 1, 2, 5, 6, and then 9, 10, 11, and 12. So the next one would be 5. You're welcome.
Yay.
Thank you.
We'll come back to number 3 though, because that uses a property that I kind of skipped over, but we're going to double back to. We're not done with it.
Hopefully not on Friday, right?
No, not on Friday. So we're going to do the integral of the square root of w plus 5 dw. When you are in trouble, you call dw. So you got to pick the innermost part for u.
I thought it was
It's a 90s cartoon, Darkwing Duck. Yep. So w plus 5.
The W takes the place of the X.
Cause that's the variable.
So then du would be just 1, and then dw. Yeah. Yeah, you don't have to do, this is easy.
My whole brain is like not working.
So you get the square root of u du integral. Oh, that one's too hooky.
I don't think this.
Oh, that's too inappropriate. U to the 1/2 du. And then antiderivative means this is going to go 2/3. I heard that.
What, Mr. Tuck?
Don't worry about it. And then you would resubstitute w plus 5 in for u. So w plus 5 to the 3rd power plus c. Right? All right. Number 6 is a tiny bit more complicated. Number 6 is a tiny bit worse than 1, but only because of fractions, and I know you guys love fractions.
Yeah.
Why is it harder than that? That's like the ones we were doing yesterday.
No, because it's 9 versus 6. It's 9x squared is du, and so you have to convert 9 to 6. Yeah. Yeah. So that, I mean, that's all that it is. You just have to deal with fractions. That's all.
It's gonna be 2/3 du.
Uh-huh. Uh-huh. So, yeah.